geometry. Here we go. Triangles. Are you ready? All right, 6:09. Got like 20 minutes here before morning math. And I'm dedicating it to you because I love you guys. All right, so let's find Christopher Newport. And we're going to go to the assignment together. All right. And in the second quarter, we're going to have little learning teams. This is something I did with one class last year, and it was a positive change. And I think it will help us foster collaboration. But right now, let's just check and make sure everyone is doing what they're supposed to individually. So I have clicked on the assignment here, and I am observing the due dates. Now, if this were me in my room, whenever I'm sitting at this computer, I have a little system. It's right on the board right here. So I would do this, I would write this in, planner, put it to all my other due dates. If I were you, if I were me, I would put it on a sticky note on my teacher desk or my work desk at home. But anyway, you see these due dates. You are responsible for them, even though the assignment says due today. I know you can handle that. All right, so let's talk about the textbook organizer. So we gotta go through those green sections, or green questions, don't we? Is that still essential, even though I'm back? All right, so congruent triangles. That's where we're going. But first, we're going to talk about triangles in general. All right. So like some of this stuff you should definitely know from, fourth grade, fifth grade, at the beginning, like acute, right, obtuse, and scalene, isosceles, equilateral. Those are the different classifications of a triangle. Right? So make sure that you write it down in your notebook right now. The different key terms here that I'll circle them. All right, so this should be, right here should be in your own notebook, You have acute triangles. Their definition is right here. Equiangular, everyone say equiangular. There's three congruent acute angles. What is an obtuse triangle? It's a triangle with one obtuse angle. What is a right triangle? It's a triangle with a right angle. All right, easy. But remember, in geometry, we must know our definitions. All right, then we build off of that. So classify the triangles. All right, let me classify this triangle here. This triangle right here, they want to know what this one? I'll tell you. This is an obtuse. Right. Do you know why it's an obtuse triangle? Because of the 97-degree obtuse angle, of course. All right. And how about this one here? 60, 60, 60. Well, it is equiangular because all those angles are the same. All angles same. We could also say it's acute because all angles are acute. All right. Example 2, classify as acute. Oh, look, now we have, this, we have three triangles here, one here, and the big one there. Okay, so use the diagram, classify PQS. So PQS, that's this triangle here. So just like we name angles with 3 letters, we also name triangles with 3 letters. But instead of putting an angle symbol in front, we put a triangle symbol in front. So what is PQS is a right triangle because angle S is a right angle on that side and also on the other side. That's not labeled. Classify by sides. We have equilateral, isosceles, scalene. You can see the definitions there. Classify the button. Where's the button? Oh, this button. Oh, the hazard light button. That is, they're all those sides. This is are the same, so that is equilateral triangle. Equilateral triangle. Sides. All right. So you can classify each triangle by side and angle. You can say, like this, I could say it's not only it's not just equilateral. This is acute equilateral, right? That's how you classify a triangle. Classify KML. KML. Okay, now we don't have all the measurements for KML, but we do have these little hash marks. Do you remember that those mean congruent? So KML is a triangle with two hash marks with two congruent sides. So triangle KML is isosceles because it has two congruent sides. I could say because KM is congruent to ML. Just using the equal sign because I don't know. This can't anyway. Find the missing value. Oh boy. Algebra. So okay, find the measures of the sides of the equilateral triangle. So you know, it's equilateral. So all these sides are the same. So of course that means I could set up some equalities like 5y minus 19 equals 3y minus 3 and solve from there. And you don't have to set up all three, just set up two. They're all the same. And yeah, so use that geometric reasoning to set up your equation. And you'll see also that practice and problem solving questions are due by the end of class. Oh, 11:11. Okay, we might want to make that 11:12. We're going to go ahead. We're going to change that to 11:12. So we want the IXL done by Friday. We want practice and problem solving these questions here. So hopefully you felt like nothing you did, Mr. Field, was really that bad. So why doesn't everyone just do this? Try, this is what we used to do back in my day. Try all the even questions. All right? Okay, so we can do that. But let's continue on to section 4.2, angles in a triangle. Look at that, auxiliary line is back. It's an extra line or segment. We talked about that. You can ask me in person as I am here in the room, but please stop what you're doing right now and write the triangle sum theorem. That the three angles of a triangle add to 180. I said it yesterday in class. I remember. I don't know if you remember, but here it is in the textbook. Very important theorem. And even the proof, right? We don't give a theorem in geometry without writing a proof for it. But you don't have to write the proof for it because it's right here. You just have to, well, you have to write the proof for it, but you don't have to know it. Right? I mean, to say it's here. So you didn't have to create it, but you have to know it. I could definitely put it on a quiz. I could put this much on the quiz and say proof. I think I'll do that. All right, so then you just know these steps. All right. You want to talk about the steps? All right, so our auxiliary our aux line there is here, and it's parallel, okay? And so what does that do? So before we even look at this proof, let me just give you the proof plan. So this parallel line creates, four angles, 4 and 5. Angle 4 is important because it has a special relationship with angle 1. They are AIAs. I wonder if you saw that. And angle 5 and 3 are also AIAs. You see that? AIAs. And we know AIAs are congruent. Okay, so that is one thing. Then the other thing is angle 4, 2, and 5 are like a linear triplet. And so they add to 180. And so angle 1 is congruent to angle 4, and angle 3 is congruent to angle 5. So if these three angles add to 180, but then I can substitute angle 1 for angle 4 because they're the same, and I can substitute angle 3 for angle 5 because they're the same, then I can write the equation angle 1 plus 2 plus 3 is 180, the triangle sum theorem. And that is exactly what we're doing here. So they just said, draw the line, parallel postulate, 4 in BAD, yeah, form a linear pair. But anyway, 4, 2, and 5. So they get here, right? The linear triplet there. And then we have the alternate interior angle theorem. And then substitution and, or the equal definition of congruent angles. Now, if I made you write this on proof, I wouldn't make you do all this. I would just say, why don't you start out by saying 4, 2, and 5 add to 180, linear triplet. We can just create that theorem. And then alternate interior angles, so substitute in. All right, let's move on. Yes, question about that. Put it in the organizer. I'll answer more questions. All right, find the measures of each angle using the triangle sum theorem. So first of all, we know this is 180, so we can find angle 1, right? And then once you know angle 1, then these three add to 180. So what is that? What's 180 minus 57? 123. So angle 1 is 123. So then angle 3, to find angle 3 is 180 minus 123 plus 28. That is, then we have that. And then angle 2 is just going to be angle 1. Angle 2 is going to be 180 minus the sum of 71 plus 57. Figure that out. Ooh, with these triangles, we got some congruent angles here. 67. 50. Okay, so we can find find angle 7. We can do that. Then after you find angle 7, find angle 6, because we got linear pair theorem with angle 7. Then divide the answer by 2 and you'll find angle 8 and 9. So then find angle 8 and 9, and I'll see in your organizer if you're able to do that. Then once you find angle 6, then you can also find 5 and 6, because 5 and 6 make a linear pair, and then finally find angle 4. Find the angles in that order. Exterior angle theorem, write this one in your notes. All right, should be so busy in class today. All right, remote interior angle. So remote, TV remote. Why do we have a TV remote? We have a TV remote because we want to sit in the chair and from a remote location, control our TV, right? All right. And a remote means far away. Uh-oh, text message. No, what is that? All right, so a remote interior angle is with regards to an exterior angle. So in this picture, angle 4 is a exterior angle, and angles 1 and 3, of course, they're in the interior of the triangle, and they are the remote interior angles with respect to angle 4. All right, so why do we even care about all that? Here's why. It's because the measures of the remote interior angles are equal to the exterior angle. Okay, so if this is 120, for example, then these two angles, if I add them together, they would add to 120. It doesn't even look like it, but it's true. The measures of the exterior angle of the triangle is equal to the sum of the measures of the two remote interior angles. And so we can use, no worries, Mr. All right. Closet organizer. Tanya mounts the shelving bracket shown to the wall in the closet. What is the measure of angle 1? Okay, so angle 1 is an exterior angle. Does everybody see that? If I hear someone say no, then I'll go walk over to your computer. All right, so the interior angles with respect to it are 40 and 90. So what is the measure of this exterior angle? Well, I can just add these two, 90 plus 40. Isn't that handy dandy? I can figure out angle 1 by knowing angles remote to it. 130. All right, so it's 130. And a corollary, please write this down, because we have, you want to know what are we talking about when we say corollary. That's a theorem with a proof that follows as a direct result of another. So you have this triangle sum theorem, and then if you can say, oh, by the way, that also means that, the remote interior angle is true, then we could call it a remote interior angle corollary or something. But okay, so we have triangle sum corollaries. The acute angles of a right triangle are complementary. So write that down. And for 2, there it can be at most one right obtuse angle in a triangle. So these are little corollaries that are also true because the triangle sum theorem is true. In our last example, all right, so we got all 3 triangles here in one seemingly rectangle. No, it is a rectangle. Okay, so find the measures of each numbered angle. Angle 2. How am I supposed to? Oh, I see. You can find that 90 and 38. You can do that. Angle 3. Well, we know this is 90. And then we can figure out this once we figure out angle 2. You could do that. And angle 4. Well, once you know angle 3, you know angle 4. All right, guys. Have a great time solving all these problems and ask for help when you need it.